Hello everyone, my name is Pedro and today I'm going to talk about a very interesting example of machine learning applied to wireless network control systems. So before I start, just a brief introduction. I'm Brazilian, 27 years old, I have a master's degree in electrical and computer engineering. Previously I was working as a protocol engineer in Samsung Research and Development, and now I'm a PhD researcher at Bosch Corporate Research here in Germany. I'd like to start providing a brief introduction about wireless network control systems. We basically have a traditional control problem with an actuator, a plant, a sensor, and a controller. And for many safety reasons, in a not very long past, everything was connected by a wire. But today, to enable especially Industry 4.0 services, Internet of Things, autonomous vehicles, and so on, everything must be wireless. There is actually very interesting examples of wireless network control systems. One of them is the Heathrow Airport in London, where these vehicles, these pods in the image, they connect people between terminals and they are fully autonomous operating. You can basically find some videos in YouTube about it. It's a very interesting application. Another interesting example is the container terminal in Rotterdam in Netherlands, where these container vehicles, they are also fully autonomous. Basically, it has been demonstrated a lot of gains in terms of efficiency, maintenance costs, and so on. As likewise, you can also find some YouTube videos with further explanation about it. It's another interesting example. One interesting fact, however, about both applications that I just described is that they basically have a common sense of operation. Where you have a cloud controller, you have the vehicles which are receiving commands continuously, commands to stop, to start, to go right, to go down, to go up, and so on. However, there is the wireless channel in the middle, which can bother this communication, which can maybe you send a command to the vehicle to stop. Because of the wireless channel, this command is not received, and then maybe an accident can happen, causing financial damages or even human damages in a worst case scenario. It is plausible to think then that, of course, you need to have strict requirements either when it comes network reliability or control system stability. However, we cannot think just in improving network performance. Actually, our ultimate goal is the control system performance, but it depends on the network. So you are speaking about more in the sense of a joint optimization. To illustrate this as an example, I can say, for instance, that a 10 times less 9 packet loss rate doesn't necessarily mean a good performance for the system, for the control system. At the same time, that 1 packet loss for each 10 transmissions doesn't necessarily mean a bad performance. So the performance here of the control application is more related of how this packet loss happened, how they are distributed, because depending of how the sequence of errors happened, my system can lose stability with very low packet loss, and if I have in the other case a very high packet loss and they happen in a certain distributed way that the control system is not affected, my control system also don't lose stability and might have performance even better. So for this reason, we have been studying such problems, and one of the recent discoveries, it was an interesting one, is that the vehicle speed directly impacts either the channel reliability and also the control system stability. In more details, is the following way. Basically, very high-speed vehicles, you have a channel less correlated, which is good in terms of transmission performance. However, as you can imagine, a very high-speed vehicle is also harder to control, so this affects the control system. One possible solution that have been trying so far is to attach a reinforcement learning framework together with traditional controllers, autonomous vehicles controllers like Stanley controller or purpose suite controller. And basically, this framework gets aware of the channel and adapts the control command sent to the vehicle. The idea is that with this framework, we can improve the stability of the vehicle. Well, basically, you have been developing some research in this regard. Adding this framework, it actually really improved the vehicle stability. But another interesting fact is that we could also be able to improve the mission time of the autonomous vehicle. It means that the vehicle was able to complete the path as fast as possible while keeping high stability. And these results we recently submitted to Globicon 2020. That's it. Thank you for your attention. If you have any question in this regard, you can contact me.